So at host level, security for the defense in depth model takes on a slightly different or slightly bigger concept. At the host level, we're talking about an entire computer. We're talking about an entire PC. We're talking about an entire Mac. We're talking about an entire Linux machine, whatever it is. So using the network nomenclature, a host is just some entity, some computing entity, whatever that happens to be. At that layer of the defense in depth model, what are the considerations, or what is the host layer of the defense in depth model? Really, it has to do with two major components, the hardware and the operating system, because we've already talked a little bit about application. We're going to talk a little bit about network. What's in between the application and the network? The operating system and the hardware. Considering that some folks do trust things like Microsoft Windows or Apple Mac OS or different distributions of Linux like Ubuntu, again, those are considerations that we make when we get to this layer of the defense in depth model. Perhaps we do trust certain distributions for some types of data or some types of workload, but for other types of workload we don't. Perhaps for people that make and edit pretty pictures on their computer all day, we give them Mac OS X, and we give them a big shiny box and a ginormous monitor, probably almost as big as this one, but probably 20 times the cost. And we let them use that stuff because in the defense in depth model, those assets, those pieces of hardware and operating systems make sense. They carry the proper workload and they don't negatively impact security. So that's fine. Versus, would you give the same gear, the same operating system, the same host hardware to someone that was managing A-level security data, secure data, or managing launch codes or secrets or military data? No, obviously you wouldn't do that at all. In your organization, you certainly have sensitive data, you certainly have less sensitive data or non-sensitive data. And that's the difference here. It's not just at the operating system layer, though. That's really what I want to drive home. It's at a combination of the operating system and the actual hardware layer, because you might trust this brand, not trust that brand. You might trust gear, hardware that's built in your country, the same country of origin. You might not trust hardware that's built outside of your country. You might trust certain components, BIOS, things like that, where you can actually review the source code for or look in depth at, versus other pieces you might not trust unless you can actually look into them and examine them very tightly, or maybe they have to go through rigorous testing. So it's both of those things that make a big difference at the host layer. And then when we talk about examples, or when I show examples of host layer security, what I'm talking about here is on the operating system level, or for the operating system chunk of that, it's really about the concept of mandatory logon, requiring logon, and securing the system. The operating system and the hardware work together to make sure that you've got single sign-on or single logon. When one user sits down, they have to prove their identity. And we'll talk about the mechanisms for that at a different time. But that's a key component of the host itself, the operating system plus the hardware. Being able to just put the keyboard in a different port or the monitor in a different port and being able to see different things or circumvent security, that's a bad thing in most cases. But again, not all cases. This is a defense in depth thought process. So there's different cases, different security postures. And then malware scanners and firewalls, stuff like that, stuff we really frequently understand at the host layer, remembering that it's a combination of the hardware and the operating system software. So your operating system might provide a firewall. It might not provide a firewall. That might be a good thing or a bad thing. You might have hardware implemented at the host that actually blocks certain ports or blocks certain types of data and unblocks other types. That's fine. Whatever it is, thinking about security at the host layer is the important component in this defense in depth threat model that we're looking at doing.